Good. All right. Good morning, everyone. Thanks for joining us. My name is Sarah Husky with 3C Ren. I've started recording this course, which will be posted on our on-demand page. We are here to talk today about the 2022 Energy Code, which is now effective as of January 1st, and how the new code applies to multifamily projects. Before we get going, though, I just have a few slides to run through. All right, please be sure to have your full name displayed. It really helps just make sure that we have everyone accounted for, and we ask that everyone make sure they're on mute. We encourage you to ask questions in the chat. We have Grant here from Inbalance that will be monitoring the chat. If you'd like to verbally participate or ask any questions, we ask that you please hold those until the end. We'll have a Q&A portion at the end. And then we can ask you to unmute yourself at that time. So a little bit about us. We are the Tri-County Regional Energy Network, also known as 3C Ren. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected through the public goods charge found in our utility bills. And 3C Ren currently offers 3 programs, the first of which is our Energy Code Connect, which is where this course is being brought to you from. The Energy Code Connect program serves building professionals by offering Title 24 support for everyone from plans examiners and inspectors to architects and contractors. We also have our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24 related questions for both residential and non-residential projects. Another program we have is the Building Performance Training, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings. And our third program is our Home Energy Savings Program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through both incentives and rebates. You may see a few 3C Ren staff members on the training today. If you see anyone with this background, feel free to chat with them directly. But with that, I'll pass things over to Jennifer from Inbalance Green Consulting.
Hi, everybody. I'm Jennifer Rennick, Inbalance Green Consulting. I'm licensed architect and also certified energy analyst. And I'm here with Grant Murphy, who's also from Inbalance Green. And he is also a certified energy analyst. And Grant is going to monitor the chat. And I am going to close the door in one moment.
If anyone has questions in the chat, I'll be able to interrupt Jennifer or respond in the chat. And if it's any really good questions, we'll follow up and take it offline after the fact. Stuff that can't be answered just in the flow.
Yes. Okay, perfect. Thank you, Grant. And today is part of a series for the Energy Code and Cal Green. Today, April 6th, we're on the 2022 Energy Code multifamily projects. Next May, we'll have Cal Green for the residential and non-residential occupancies. And then May 17th, we will have the Energy Code 2022 updates for non-residential. If you've missed some of the others, I believe pretty soon they're going to be on demand. Sarah can chime in on that.
Yes, yeah, they are on our on-demand website.
Okay, great. Thank you, Sarah. Today, we're going to review real quick the Energy Code triennial cycle and just highlight a few of the Energy Code reorganizations, And then we're going to go into the multifamily residential, kind of the high level changes, some mandatory measures that have been updated, performance prescriptive method changes, and hit on a little bit of additions and alterations. And we'll hopefully have a little time for questions and answers to get to all questions. But like Grant mentioned, if you put them in the chat, we'll be able to take them as they come if it's applicable to the slides. One of the kind of key things with the California Energy Commission and Title 24, and depending on how long you've been in this line of work, you may or may not know that the California Building Energy Efficiency Standards and all of Title 24, which includes our building codes, they're updated every 3 years. And it's a process that includes industry stakeholders, in-house expertise, and the general public. And all the decisions that go into the energy code have to be proven that they are cost effective. Some of the big picture goals for this code cycle for 2022 update is to encourage heat pump technology for space and both water heating, and to establish electric ready requirements for single family and the multifamily projects we're going to talk about. And that includes expanded PV systems, so photovoltaic solar systems and battery storage standards that are now applicable to multifamily, both low rise and high rise. We're going to focus a lot of what we discuss on the Tri-County regional area, which is, 3C REN covers the tri-counties of San Luis Obispo County, Santa Barbara County, and Ventura County. And often I'll highlight examples that are applicable to those climate zones that hit 4, 5, 6, 9, and 16. So the newest 2022 building code went into effect January 1st of this year, 2023. And if you would like more information on the specific code language itself, that's available at the energy.ca.gov website. And you can also just Google, California Energy Code Standards, and it'll take you there. And also on 3C REN's website, we have a resource library through the Energy Code Connect. And we also have links directly to the most recent codes, which I find this link, whoever put this together, Sarah did, made it simple. So it's nice to have it there. The energy code for multifamily has essentially been reorganized to accommodate the multifamily standards. And what I mean by that is that that multifamily occupancy type was kind of pulled from what was called the residential standards and pulled from the non-residential standards and combined into its own multifamily standards section of the code. But before we get into that, I'm going to go over a little bit of what this looks like for the subchapter reorganization. And I included this information for folks who actually need to take the time to go into the energy code itself. So I'm going to give you a little comparison. So under the 2019 code cycle we just had, we had a section for all buildings, sections for high-rise residential, and then all the non-residential hotel motel sections, and then a section for low-rise residential. So that's 3 stories or less. Now under the 2022 code, we still have our all building sections. We have our non-residential hotel motel sections. We have our single family residences. That includes duplexes and townhouses. But now we've got this whole new section for multifamily buildings, including both high and low-rise residential. For those of you who are visually oriented, oh, and by the way, you will be getting a copy of the slides. So you will have these as reference. But for those of you who are more visually oriented, I put a building tree out there. So you've got your big categories for everything that is all your mandatory measures for something that hits all occupancy types. And then we had subchapter 7, 8, and 9 that was specific to low-rise residential. And then it was basically everything else that wasn't low-rise residential. And now we've got our not residential sections, our single family and our multi-family. And it has its own 3 chapters that kind of mirror the organizational structure that the single family residences followed. So if you're used to looking those things up in the energy code for single family, the multifamily follows that same kind of hierarchical organizational structure. And the one key difference now under the multifamily residential portion is it's now trying to address within the code common areas that typically are not in the dwelling units, and you would have found them in the non-residential section as kind of a separate part from the high rise, even if you're in a low rise occupancy. So now they've combined it so you can go straight to this section to also find out about the corridors, lobbies, staff rooms, lounges, community spaces and other shared spaces. The multifamily residences have a few high-level changes that are kind of applicable to all of the sections, which is that there's been updates on the dwelling unit ventilation. There's been updates on domestic hot water requirements, some space conditioning requirement updates, a few lighting changes, not many actually. There's something called electric ready that you may have heard about for low-rise residential, which is applicable to the dwelling units of the multifamily. And then there are photovoltaic and battery requirements. PVs were required for single family residences under the past code, but now under the new code, photovoltaics are required for the multifamily, high rise, including and non-res occupancy types. And there's also a battery component with that. And a number of the changes, like each code cycle, this is kind of typical, that a number of the changes that were part of energy efficiency under the old code cycle get moved to mandatory requirements, and then new requirements prescriptively and optional performance method requirements come into play. There's a little vocabulary review I want to give you. You're going to hear me talk about mandatory requirements, and that's a reminder it's applicable to all the projects regarding energy efficiency. And in this case, we're going to talk a little bit about a couple of them that are all occupancy, but mostly multifamily. And then there's the performance method, and that also means your energy modeling approach. So you can do trade-offs amongst requirements under that approach, but all the mandatory requirements are still applicable. And there's also the prescriptive component package, or essentially we call it like a checklist approach, sort of following a recipe card. And it's this checklist under the prescriptive component package that becomes that baseline for your performance method that you're going to compare to. So as we go through the prescriptive component package, if you choose to do everything under the prescriptive method, you follow all the parts of the checklist. But a lot of our clients will learn what the prescriptive requirements are, and then when it comes to their actual design, we'll run a performance computer method so they can more or less kind of try to pick and choose and optimize which of those prescriptive component packages are most appropriate for their project. There's a new metric when you do the performance method or computer modeling, and it's called source energy budget. And this source energy budget is basically being used as a proxy for carbon emissions or carbon footprint. So it's a little different than our old metric, which is TDV, time dependent valuation. And that is still part of the what you have to do to show compliance. But the source energy now adds on another layer that's specifically associated with the pollution, the carbon emissions and other related pollution emissions associated with the distribution and creation of the energy. So here's a graphic to kind of give you an idea of that. Source energy includes the building, that includes the wind power, solar power, the gas peaker plants, includes all of it, but now it's being used as a proxy for carbon in new construction. And then TDV continues to be the metric for both what's called an efficiency score and a total TDV score. So what that looks like now in the compliance form is an excerpt from that is your building complies if it shows pass under the time-dependent TDV valuation, both in terms of efficiency measures and total, which includes your PV battery, and then your source energy total as a proxy. I've played around with this a little bit now on a couple of projects, and I've had my projects pass under the TDV, no problem. And then I'll have a source energy score where it doesn't quite pass or it's barely passing. And if you look in this example, this one's just barely passing at 0.07, which is good enough to get your building permit. But that carbon, that'll be an interesting thing to play with. I don't know, Grant, if you have had much time to play around with that carbon proxy and see where it lands. But what I found is that I could add more PVs or swap out some gas water heaters to heat pump water heaters, and that took care of that carbon proxy. For all of the changes for all the changes for all of the occupancies, sections 110 through 110.12, it's mostly going to affect the non-residential spaces, but because multifamily buildings include some common non-residential spaces, some of these mandatory measures are going to come into play. And it mostly has to do with the equipment efficiencies of the heating and cooling equipment is what I've noticed. Otherwise, a lot of those overall mandatory measures haven't changed that much from the 2019 to the 2022 code. Now, there is a section under these mandatory measures that I think is worth reviewing for folks, specifically addressing the mixed occupancies, which you have with many multifamily buildings. So in other words, you may have a large portion of that multifamily building being actual dwelling units. So that would be a residential occupancy. And then some portion of your building is going to have maybe common corridors. It could even have a manager's office. It might have a small cafe, or it could have retail space. Depends on the scale of the project. But what's important with this section is it spells out that you can follow sort of one set of guidelines if 80% of that conditioned floor area is associated with one occupancy, such as the dwelling units. But you might have 20% of that occupancy that's now associated with the common spaces. And those common spaces, non-residential occupancies, would have to comply with the mandatory measures and the lighting measures and a lot of the glazing and wall assembly that are associated with the other occupancy if you truly divide it out. But mostly this is going to point you back towards following the applicable lighting requirements and ventilation requirements. That was probably a long way to say that. Grant, if you have a faster, easier way, just chime in.
Not yet.
Okay, this new section under multifamily, section 160, it's broken out into a general scoping, the building envelope, then ventilation and indoor air quality, space conditioning systems, water heating systems, lighting, indoor and outdoor, electric power distribution systems, covered processes, solar-ready buildings, electric-ready buildings. And if you're familiar with the building energy code, you might look at this and say, wow, it's kind of a mash between what I would see in non-res standards and the residential standards. So it follows along all the things you would have in the residential occupancy, like your envelope, your indoor air, your space and water heating systems. And we'd have some mention for lighting, but because this is multifamily kind of mixed occupancy, now we're looking at lighting indoor and outdoor that is very much like the requirements in the non-residential standards. And so the electric power distribution and covered processes and solar ready, electric ready, that's like similar to the non-residential standards. So there is a blend of that in this part. And it does mirror those non-residential occupancies in that mixed building. You'll find some of it addressed under this section, but in some cases, it will just refer you to the non-residential standards. For the indoor air quality, IAQ, the big picture change really has to do with the structure of this being pulled together, both residential, non-residential, and it's broken into, is this building 3 stories or less or 4 stories or more, which was the old way to look at our multifamily occupancies. It still is, except now it's all under one big section. So you've got attached dwelling units that were going to follow the residential code essentially. And nothing's, those same updates apply here for 3 habitable stories or less. And you're going to need HERS verification and diagnostic testing for that. But the other part of the space, the other occupancies, and for residential projects that are 4 stories or more, you're going to be following essentially the same way the non-residential code is laid out. And you're going to look into a different section for HERS requirements under the non-residential appendices. So it's not exactly all clean and cut. They're still cross-reference both residential and non-residential standards depending on how tall the building is, but at least the bulk of everything you need is now in the multifamily section, those 3 chapters, even though it may reference you back to an appendices that's part of the residential standards or an appendices that's part of the non-residential standards. And just quick reminder, all this stuff, all these sections I'm talking to as far as being multifamily, it's not applicable to individual townhouses or an individual parcel of land that only contains 2 dwelling units, like a duplex. Those are still considered single family residences. And also, there is some language now in the code to remind all the designers and the mechanical engineering folks and the people working on the plan set that the outdoor air ventilation rate and air distribution system design shall be clearly identified on the building design plans. And I know that the folks who do the plan check will appreciate to see that on the plans and have it be consistent with your Title 24 reports, which is something that I've seen come back as plan check correction. Now, the new 2022 code under the dwelling unit indoor air quality has had some updated and additional language added, and we'll touch into that a little bit more. And there's clarification around something called an integrated central fan ventilation system. I have a slide on that next. There's been some updates on kitchen and bathroom exhaust, and a little bit of clarification on balanced ventilation and heat recovery and the fan energy allowed for that, depending again on if it's single family or I'm sorry, not single family, but a low-rise multifamily or high-rise multifamily. Those requirements are different. And some testing of those ventilation air systems. The main big takeaway though is that, main takeaway is that ASHRAE 62.2 continues to be the basis for the dwelling units, for the actual dwelling units, residential occupancies, and that ASHRAE 62.1 continues to be the basis for the common space or the non-residential occupancies. So there's still consistency with occupancy type, how much ventilation is required. Now they've put it into this section so you can just go to one chapter to kind of see everything you need for your multifamily project. For the projects that have tried to go forward with being able to introduce fresh outside air into their dwelling unit using the central fan that's part of the air handler for a ducted system, there is language to clarify what you must do in order to do it that way. And it does require outdoor air dampers and specified damper controls. And there's been language that clarifies how they should operate and clarified that there's controls that need to allow for variable ventilation. But the main premise didn't change, which is that you're still not allowed to use the main air handler fan and to run it continuously to bring in your outside air ventilation, because that has been shown to use too much energy and be an unnecessary large volume of air for how much usually is required for outside air. Most common ways still probably to introduce outside air is to use a local exhaust fan that runs continuously. And although that's allowable, it does mean that for a multifamily project, you would have to engage your HERS rater to come and test that each of those dwelling units are self-contained and that you're not having too much air barrier leakage between the dwelling units. So one way to resolve that is to use what's called balanced ventilation. And that means you could use a balanced ventilation either through pulling air outside directly and exhausting it directly on each dwelling unit, which would include some positive supply, or you can use an ERV or HRV system, and this would allow for some heat exchange and greater efficiency. And so depending on the size of the dwelling unit, sometimes you can buy these integrated as one system, like Panasonic makes it, or you could buy a separate supply fan, exhaust fan, or I'll show you a example of a ERV, what that looks like in our prescriptive requirements. I've got a slide on that. The main premise here also for these systems is that they can be turned off by the occupant, because there are times when the outdoor air quality is very poor, such as for forest fires or other really bad air pollution. So they're supposed to run continuously, except the owners can turn them off when they need to. When it comes to the kitchen range hoods, this section is new, and there's a new metric called a capture efficiency that's being, kitchen hoods are being rated for their capture efficiency, meaning how well do they capture the steam and the air and the particulate matter that's coming off of your range or your cooktop and actually entering into the hood and being exhausted to the outside. And just as an FYI, I still not too recently, but fairly recently have seen some multifamily projects where the builder did not duct the hoods to the outdoors, was working on making that project more cost effective from the builder's perspective, and using a recirculating ventilation hood, that's tied to a microwave. And that's technically not allowable. So the fix was to add a secondary fan to that entire kitchen that met the CFM requirements for that space, which then in the end added cost to the project. So just kind of a FYI heads up that microwave style recirc fans above the range is not appropriate, and it needs to exhaust to the outside. So what this requirement now says is that, for example, if you've got an electric range or an induction range, which is also electric, and you have a hood efficiency, capture efficiency of 55%, that would be appropriate for a dwelling unit area of 750 to 1,000 square feet or larger, but you could not have a dwelling unit any smaller than 750 square feet, nor would it be appropriate for a hood over a natural gas or propane range. And the thinking here is that the larger the dwelling unit, the more any particulates, air pollution coming off of the cooking appliance can be diluted within a larger volume of air. So the actual capture efficiency and the actual CFM it pulls doesn't have to be as high. But if you're in a small apartment, just a little bit of pollution coming off of that gas cooking appliance is significant because it's concentrated into a smaller volume of air in that smaller apartment. So you would have to have, let's say you had a 500 square foot efficiency apartment, you would need at least 280 CFM put over your gas range. And the reason for that is the EPA has done a lot of testing over several years. I think I first learned about this about 10 years ago. So they have about 10 years of data, at least, that is showing that the people's increased risk for asthma and other lung conditions is significant, you know, statistically significant. When it comes to that mechanical exhaust kitchen bathrooms system, they do need to be tested to show that they can pull the correct amount of CFM and, or, you know, you're meeting that capture efficiency. If you don't want to show it that way with the tested system, you can follow a prescriptive requirement and just show that, for example, the duct length is no greater than 25 feet in length and it has no more than 3 elbows, and that it also meets some other requirements with the termination fittings and how it's exhausted to the outdoors. When it comes to lighting, there has not been that many changes, and the mandatory measures really is to clarify that a lot of the lighting sources are LED, and a lot of those specific requirements for LED lights, they are pulled from what's called the JA8 requirements because the LED light sources are considered to be high efficacy. So there's some clarification around that, and there's also some clarification on recessed luminaires. And then the one thing, though, for this section in general is just that there's a section A that deals specifically with the dwelling unit lighting, and then there's a section B that now deals specifically with the non-dwelling unit or common space lighting, the parking garages, outdoor lighting, and here's one of those cases where it's pulled out separate. You can see it here, but then it's going to refer you back to section 130, which is the non-residential standards. So there's still a little bit of back and forth on some of the requirements, but at least in one place, you can right away see how you're going to apply the lighting standards to both the dwelling units and the non-dwelling unit areas. For the electric power distribution systems, again, actually very minimal change, and it's in the multifamily section of the code, mostly to clarify that this electric power distribution system, these requirements that you typically would find in the non-residential standards are applicable to those portions of the multifamily building that are not a dwelling unit. This is a kind of a new section for both the single family and the multifamily. Rather, it's repeated in the multifamily part of the code, but this requirement is the same language, but different code sections is repeated in the single family. And this is part of the electric ready requirements as California moves more and more to having electric appliances that are more energy efficient, have a lower carbon footprint than gas appliances. So the code doesn't say you can't install a gas appliance. What it does say is that if you install a gas appliance, you have to have the infrastructure, the appropriate outlets and conduit and wire run for a future person, future building owner, future remodel to easily swap out the gas appliance for an electric appliance. And that holds true for dryers, both in the individual dwelling units and in the common spaces. It holds true for furnaces that you might have in individual dwelling units, but would be ready for future heat pump installation. And that also holds true for the water heaters. Part of this electric ready requirement is that the sub-panel would have to be labeled and have everything set up to be ready for an electrician to come in and just use that part of the panel and already have the conduit and the wiring in place. And the end that you would either attach into your electric box or in some cases plug in to the electrical outlet, that has to be within 3 feet of that non-electrical appliance location. Or in the case of a furnace, sometimes if the furnace is located in an attic, for example, like on a low-rise project, it may not make sense to put the electrical outlet next to that furnace, but you would need to make sure it was all set up to accept the heat pumps for the outdoor condensing unit in an appropriate location. Before we move on, are there any questions on the kind of those mandatory measures and updates, or
We
anything
just
you
had
want to
our
add?
first one. John asked how we would determine the capture effectiveness, the capture efficiency of range hoods. He's never seen it on a spec sheet.
That is a new metric, and not every hood manufacturer has done the testing to have their particular appliance tested yet, but that's going to be coming on board more and more. And then at some point, it'll be a requirement that the manufacturer include that metric. So right now, it's going to be hit and miss. It's kind of a heads up to everybody that if you do have a manufacturer that does list their capture efficiency, that CE, you can use it, or contact the manufacturer to find out if they've done the testing yet and just haven't reprinted their cut sheets.
Thanks.
Okay. Under the prescriptive changes, or the prescriptive, we're going to hit on the changes rather, some of the highlight changes, but the prescriptive section now hits on the building envelope, daylighting of large enclosed spaces, which is similar to the non-res standard space conditioning systems, water heating systems, lighting, both indoor, outdoor, signs. And then we're going to look at the photovoltaic or PV solar requirements. And it's a little different, 3 stories or less and 4 stories or more. I'm going to spend a little bit of time on those PV systems, and you will get the copy of the slides because this is a new requirement, and I believe we have a lot of architects or designers on the call, and so there's some rules of thumb and formulas, and you'll get a copy of the slide that you can use to help you get a handle on how much space you're going to need for the PV systems for your multifamily projects. Real quick on the envelope measures, roof and ceiling insulation. Prescriptively, it's laid out as 3 options, even though it's called B, C, and D. But B is attics, where you have ducts in the attic, and option C, it's also attic, but now your ducts are interior or in conditioned space. And then option D is a non-attic roof, or like a cathedral roof. And there's really very few changes between the 2019 and the 2022 code. Now, with that said, just kind of as reference, for those of you who actually look in the code and are looking at what's required for insulation, if you've got ducts in the attic, for example, and you're in climate zone 6 or climate zone 5, it's still an R30 insulation on the ceiling and a radiant barrier. Really, there is not much that's changed in this requirement. If your ducts are within the conditioned space and you've got, for example, you're in climate zone 5 or 6, you still have that R30 ceiling insulation, and your radiant barrier, and not much has changed. What changes a little bit is like when you're in the colder climates, climate zone 4 is a little different than the previous slide than this, but the milder climates, the requirements basically the same. Now, what is new is because they've combined the res and the non-res, or the multifamily. I keep calling it non-res, but I mean high-rise multifamily and the low-rise multifamily. Since it's combined, there's a little bit of change on what's required for cathedral ceilings, and it's by assembly type. So there's some recognition in the code that you may be framing this out of metal because you have a metal building. So the metal building U factor, and again, it switches now to a U factor and not an R value, which as I go in my head between R value and U factor back and forth without thinking about it. And as I'm talking to you all, I realized that a U factor of like a 0.041 might not mean anything to you folks, or unless you do the code as much as I do. So this is something to be aware of when you see this U factor. Okay, you got it. If you're an architect, you're going to have to dig up your old building science class or talk to your energy consultant to translate. And then for wood frame building, for example, 0.034 U factor, that's essentially your R30 to R38 cathedral ceiling. And then the metal frame building, it takes into account you're going to get some thermal conduction through the metal frame, so the U factor is higher to account for that. Under the wall insulation, it's a little bit different, the tables, because they're taking into account framing wall type more so than they did under the old code. So again, you would have, if it's a metal building, you're going to have a different U factor than for the wood framed section, and also if it's a heavy mass. So we have no change for framed structures and a 1 hour fire rating and a light mass walls. Those haven't changed, but they now have added new sections for metal framed and framed that are higher than a 1 hour fire rating, and walls that are heavy mass, which would be like solid concrete or something similar. And same concept for the floors and soffit insulation. I'm not going to go into all this in detail. It's very tedious, but I want to point out big picture that depending on the structure, whether it's, wood frame or raised mass, which means like concrete, those requirements are the same, but now they've added a category that basically includes all other that's not listed above. So as you work through this stuff with your energy consultant for what you need in the envelope, it is going to change now depending on what structural system you're using. For quality insulation, QII, quality insulation installation, that a HERS rater would look at, there's essentially no change for low-rise residential buildings. QII was often required under the 2019 code, and it's still going to be often required under the 2022 code. Prescriptively required, but could be a trade-off under performance method. That part hasn't changed. And there is some change for, well, rather, it's still, QII is still not required for high-rise multifamily. Under the fenestration, windows, low-rise was pretty straightforward on what was required for the windows. Now, with it all being combined with the high-rise residential, it's a little more complex. And again, you're going to be looking at climate zone, which is different than the old non-res. It wasn't really laid out by climate zone, but it is under the multifamily section. But it's broken down into whether or not you are going to have a curtain wall, and then perhaps you might have a different system, and then you're going to need to go into the next column and look and decide if is it part of the 3 stories or fewer, 4 stories or more, and then also what is that window to floor ratio, what's that window to wall ratio, and skylight roof ratio. So prescriptively, you need to follow each of these as you go into the tree. Make sure you match. I don't know many teams that are using prescriptive method as an overall approach, but I point this out because this is what is going to be used as the baseline for your performance method. So depending on what windows you use, it could have a large impact, or it might be a way to maybe mitigate with something else in order to use the windows, the type you want and where you want it. There's a little bit of change on the exterior doors, and the main point here is just to say that if it's a dwelling unit door, it has one requirement. And if it's a common use area door, entry door for all the common spaces, they have a different set of requirements, which is more matched to the non-residential standards. For space conditioning, just the dwelling units only, it's again broken out to 3 stories or less, or 4 stories or more. And the real kind of nuanced part is to look at this and see which climate zone you're in. But for most of the climate zones we're dealing with, like 3, 4, 5, 6, and 9, the space conditioning system shall be a heat pump. And if you choose not to use the heat pump in a performance method, the heat pump is going to be what you're compared to. So that's a pretty significant change. And for the 4 stories or more, about the only difference is that climate zone 1 is now included with climate zone 16, and it could be a dual fuel heat pump, meaning in this case, dual fuel, meaning it could be gas and electric heat pump with the smart controls in there to be able to use the gas heating when the efficiency isn't there for the electric heat pump. Here's that ERV, HRV system I was mentioning under the mandatory measures. So as a mandatory measure, you can use an ERV and HRV, and you wouldn't have the dwelling unit compartmentalization component if you use balanced ventilation. And this balanced ventilation, if you do use it, there are now certain requirements that you have a certain fan efficiency for the ERV, HRV, and that is also dependent on how you're heating the space, and if it's 3 stories or less in a particular climate zone, 4 stories or more in a particular climate zone. It's nuanced. So without going into it too much more than that, just know that it's there, and then you're going to want to work with your energy consultant or someone on your team who will dig into these requirements. It might be your mechanical engineer to have the project have the appropriate system with the appropriate efficiency, fan efficiency, and recovery heat efficiency. And for those of you who are not super familiar with the heat recovery ventilation system, where the system is ducted so that outside air, in this case, outside air might be quite cold, and as it's entering into the supply air, it is being heated with the exhaust air that's already warm, that's being taken out of the space, and that heat is being transferred into the incoming air. So now the exhaust air is cooler and the incoming supply air is warmer. And these two air pathways don't mix, but they transfer through a thin walled membrane that allows the heat to be transferred between the two flows of air. When it comes to the fan power allowances, this part is different from the 2019 code. This is just an excerpt of the table, but it goes on quite a ways, and I'm just pointing it out to you all that if we do have any of the mechanical engineers on the call, just FYI, go into this part of the code and take a look at it. And if not, for the architects and plans examiners, etc., just know that this is also part of the prescriptive requirements, which oftentimes, again, they're probably going to be doing it performance method, but well, no, I take that back. Not always. But a lot of times the mechanical systems are just run prescriptive. So if they do that for these outside air systems, or it's often called dedicated outdoor air systems, or DOAS, DOAS, there are certain fan efficiencies based on how much CFM, which cubic feet per minute of air, is coming into the space, whether it's a multi-zone VAV system and the size of it, or if it's a different type of system. And these are similar to the non-res standards, and this also varies depending on whether the supply system is of a certain size, serving a certain number of floors. It also has to do with what size filter is in the system, because that affects the static pressure, which affects your fan and your fan efficiencies. And so this table goes on and on. And the main idea here is to give credit to fan components that are saving energy and to adjust for that filter pressure, filter pressure drop, which was avoiding a loophole in calculating a mid-life pressure drop for filters. And that already might be too detailed for some of you, but it's there. Okay, you know what? Grant, Andy goes, reel me back in. So jump in or go, wow, that's super interesting, Jennifer. I bet it's too detailed. But you guys in the chat also, you'll get a copy of the slides, and you can always contact our Code Coach service for any of this. When it comes to the domestic hot water system, we've got a requirement for individual dwelling units, heat pump water heaters for multiple dwelling units, meaning 8 dwelling units or more, or you could have a gas or propane system for multiple dwelling units. Even under the individual dwelling units, you can use a gas or propane instantaneous water heater under certain conditions. So what that means is that you need to basically go in the code and take a look at what climate zone you're in. And then based on that, you can take a look at your hot water heating options. And here's a kind of a graphic of what that would look like, where as long as your gas on demand unit goes to each individual dwelling unit and it has an input of 200 kBTU hours or less, you can use it. Otherwise, you have a couple options on heat pump water heaters that you can use. And for the central domestic hot water systems, meaning 8 units or greater, the main takeaway here is that the language has been clarified on what you're allowed to do for those heat pump water heaters. And in all cases, they are split systems where you've got the unit outdoors that takes care of the heat pump water heating, the outdoor condensing unit, sometimes it's called, but it has all the components of the heat pump water heater system. And then through hot water piping, it sends that now heated water to tanks to be stored, and it clarifies that you need another small tank typically as a way to provide the recirculation for that project, the recirculation loop. And these requirements are spelled out prescriptively. Probably one of the biggest changes for, say, your gas or propane system, which is pretty typical for multifamily, is that you don't need the 2 recirculation loops. And so that, if we've got any mechanical engineers on the call, otherwise we still have that same requirement of needing solar savings fraction. So solar hot water, if you're using a gas or propane system, that requirement is still the same. But we are seeing more and more projects that are moving to heat pump water heaters for their central system. Lighting, there's very, very little changes. And basically your dwelling units have the same kind of lighting requirements that for the single family, which is true from the last code. Common areas are following the non-res standards, outdoor lighting, sign lighting, outdoor standards. And there's just been tiny amount of changes in that. For the common area allowances, they're slightly less lighting low density, meaning how many watts per square foot. And there's been some clarification on how to calculate that. If we have any electrical engineers on the call, or when you work with your electrical engineering team for your multifamily project, they're going to be familiar with these requirements. Not much has changed. So from the designer's perspective, I don't see that the architect has to worry about it too much, but just kind of a heads up that as LED lighting has become more efficient, the requirement threshold is dropped down to match. Outdoor lighting, probably one of the significant changes is just how your property is classified, whether or not it's considered moderate or moderately high level of lighting allowed, and that is based on the 2010 US consensus. And so they're not considering the moderate lighting area to be rural, but they're calling it urban clusters. And I noticed this came up on a workshop I did with 3C Ren. And I think this is a new change that not everybody has been kind of alerted to. So I know that not all of some of the planners and the engineers I had talked to during this workshop were familiar with this new definition. So this may come into play and it may change the lighting a little bit for your project. And this is more applicable to your to the engineer, your electrical engineer, but the main change from 2019 to 2022 code is just how they're going to be able to calculate your baseline for your general hardscape on that multifamily. And the end result is you'll end up with probably a little less energy for your lighting system, but your designer would still need to meet, all the requirements you would want for lighting. Meaning people still need to be able to see what they're doing and get into their cars, for example, and be safe. But how it's calculated has changed a little. Solar PVs. This is probably the biggest section of change for us. And I have a few slides here and some methodology to kind of show you how you can calculate how much PV or solar voltaic is going to be required for your project. But before I dive into that, was there any other questions on some of those kind of big picture prescriptive changes for multifamily? Okay, that's fine. I feel like with a multifamily, it's a new section, and it's a combination of single family and what we would think of, single family, low rise, because in my brain, I'm so used to thinking of that in the other code section, and high rise, low and high rise now being combined in a multifamily, that there's just a lot of material in there. So you'll get a copy of the slides and you will be able to contact Grant and or me.
We just had one come through, Jennifer.
Oh, okay, Code Coach.
About hot water units.
Yes.
Can you have an electric on-demand hot water for single units? Can you add a on-demand electric to a heat pump system or solar thermal as backup? So 2 questions there.
Yeah, so just the on-demand electric standalone, those were approved for ADUs and in the residential standards for very small apartment or small dwelling units rather, and very compact, and you had to have point of use. And under the multifamily, there's not allowed unless you could have technically an ADU or a junior ADU technically as part of your multifamily project. And then that one portion potentially could qualify to use it, but I don't know until I dig into the nuances of it. But otherwise, typically, no, not for all your dwelling units. You could do a heat pump, or you could do an on-demand gas if you want to do it for individual units.
And when you throw out JADU and ADU, it's not always the same thing that jurisdiction and planning is calling it ADU and JADU. It's a ADU and JADU by energy code, right?
Yes.
So slightly different little definition and designation there that we're still fighting through.
Yes, that's correct.
What about as a backup? Can you have that on-demand electric as a backup to the heat pump system or the solar thermal as a backup?
Well, not exactly. How it works with the heat pump system is if you're using a heat pump for multiple dwelling units as like a central heating system, you're going to have a loop tank, and that loop tank will have electric resistance. And that loop tank and on demand is electric resistance for the most part, except that there is a new product. I can mention that here in a second. That electric resistance loop tank is going to be part of the requirement or the design, and it's kind of spelled out. When you look into the regulations a little more, it gives you an idea of how many dwelling units you're accommodating and the heat pump capacity, how much storage you need, and then it's the loop tank is sized, all of that together. Now, there is a new product that's come on. I think it's supposed to be up for sale now, 2023, but it is they're calling it an on-demand heat pump. It's very interesting. I don't know a lot about it. I'm just digging into it. Instead of storing the hot water, they're storing the energy in a battery system. So from a space allocation, I don't know if you save that much space, but from a weight, I'm sure the battery weighs more. But you wouldn't have a tank of hot water sitting there. You would have batteries, which could hold the energy you need and use it when you need it. And it could be part of resiliency. It's a new product that's
I'm sure we'll talk about it in 6 months.
Exactly. Okay, I should move on to the PVs.
Thanks for the question.
There's some new stuff coming out now all the time in California because of a lot of these code changes and where California is going. Okay, so PV system, it's basically been required for our low rise 3 stories or less, but now it's being required for the high rise 4 stories or more. And it's still based on how much roof area is accessible to the sun. In other words, if you have a project that truly is in natural shade and you can show that you don't get enough sun, you could apply for an exemption for the system. But otherwise, I tell most all our designers we work with, just assume you're going to have the system unless you know that you're going to apply or meet an exemption. And you can put the PVs on carports, on the roof of the structure, on trash enclosures, any system that's capable of supporting the weight of the PV system is allowable for your multifamily project. For PV systems that are 3 stories or less, the formula is based on a conditioned floor area and the number of dwelling units within the project. And in this case, this particular multifamily project is a cluster of duplexes and quadplexes. And so we looked at what would be the PV requirement for one of the 2-unit buildings. And they used that formula based on climate zone 5, and we came up with the project would need, I rounded up to a 3 kilowatt system, just give you an idea of that. I think that, maybe 10 panels, 10 PV panels, would typical panels would probably do it. If you do this calculation and your PV system size is less than 1.8, and that it can be 1.80. So I've had that question come up. If it's less than 1.8, you don't have to put in the PV system. And if you do include a battery, you can reduce the PV system size. And this was all worked out to be cost effective. You can follow the formula, and I'll give you next, there'll be a slide that gives you the tables, those values for the A and the B. If you have this is another project with a PV system size for 3 stories or less. And in this case, we had 27 dwelling units and conditioned floor area of over 16,000, climate zone 5. So you can take your look at it as a building as a whole, or in the prior case, we just broke it out to each individual like cluster of buildings and distributed the PV. And this is an example for you guys that you can look at and follow. And here are the adjustment factors for the A and B based on your climate zone. So the PV requirement does change based on your climate zone. For PV systems that are 4 stories or more, the requirements are slightly different. It's still based on a conditioned floor area. Doesn't matter so much the dwelling units. The PV system size exemption has been increased to 4 kilowatts DC instead of the 1.8. It's also based on a overall PV system size of 14 watts per square foot times that SARA, that available solar roof area. So in other words, you get to choose between this formula or the 14 watts per square foot of your SARA solar roof area, and choose whichever is smaller of a requirement. It's also going to change a little bit with your project being mixed use and not mixed use. This, instead of this formula being based on climate zone, it's actually based on climate zone and the building use. So in this previous example, we were looking at climate zone 4, and we were calculating it I think I just caught an error. I am going to recalculate this and send you a new slide. I apologize. I will send out the slide deck. But for high-rise residential, you come in here for climate zone 4, and you would be using a factor of 2.21 in that equation. And depending on your mixed use categories, you might actually have a portion of your project that's retail. If it's a high-rise residential, retail portion may have one requirement for PV and battery, and then your high-rise residential portions are going to have another requirement for your PV system. And then those would be combined for your whole project.
And Jennifer, just wanted
Yes.
to give you a time check. We have about 10 minutes left in the course.
Okay, and this the last part goes quick, and there's a battery storage requirement, and I put the formulas in here for your use. It's based on your PV system size, and you'll probably want to reach out to your energy consultant or your electrical engineer to help you get that squared away on the requirements. And then I put this slide in here just as something to have in your slide deck in case you weren't familiar with what to look for on a PV module for its size, its wattage, just to give you an idea that once you know what your system size is supposed to be, you can calculate how much area that would take based on a PV panel. And this is the example. And give you a little more clarification on what that solar accessible roof area is and what it means. For the additions and alterations, it's a little nuanced. It mostly follows the low-rise residential, the single family. And this is broken into kind of the general requirements and then additions, whether it's prescriptive performance, and then alterations. Those have their own mandatory requirements, prescriptive and performance, and then whether it's repairs or whole building. This really matches very, very closely with the single family residence occupancies. And starting with that, probably one of the biggest changes is that climate zone 2, 4, 8, 9, and 10 got an upgrade for the roof and ceiling insulations to an R38. So maybe new construction, you might only require an R30 in your attic, but under additions, alterations, it's the R38. The ventilation for the indoor air quality, there are some exceptions. So like we're saying, per the energy code, if you do a junior accessory dwelling unit, you don't have to worry about meeting the indoor air quality ventilation section. Or if you're doing an addition to an existing dwelling that's less than or equal to 1,000 square feet. So you may have a caretaker's residence and do an addition to that. You wouldn't have to meet the ventilation indoor air quality. But if you do trigger any of these, you must comply with those other mandatory measures in the sections we went over previously for indoor air quality and kitchen hood ventilation, exhaust, et cetera, et cetera. It's nuanced if you're replacing your roof. If you are doing roof alterations and you are replacing 50% or 2,000 square feet of the roof, you'll want to come into this section because it's nuanced on what the requirements will be for the new roof and insulation. Probably a new section, but it's pretty interesting, is now for certain climate zones, you would even exceed the roof insulation or ceiling insulation to an R48. R49, which is even higher than the R38 addition or the R30 that you have in some climate zones. And there's clarification on what to do with existing recessed downlights and fireproof covers. Been some clarification that when you do these alterations that you must include air sealing. And if you're not familiar with that, I guess for the builders and architects on the call, the U.S. Department of Energy has, I think this guide is great for just what does air sealing really look like. And when you see it in a picture form, it seems pretty simple, straightforward. And there's been some new requirements and triggers for altering conditioned space heating system in the ducts. So there's duct leakage, allowable duct leakage has dropped, and now 25 feet trigger instead of 40 feet. So if you are doing alterations on that, I would come to this section and make sure you're compliant. And last but not least, if there's an existing ductless electric wall heater in the unit and you're doing remodeling alterations, you can keep it or use it, but otherwise, just FYI, ductless electric wall heaters typically are not allowed, and you would most likely want to move to a heat pump. And for the indoor air quality, almost the same requirements as everything else we went over. Main thing being for additions and alterations, that if you're replacing 75% of the ducts and all the materials associated with it, it's considered a new system. And once it's considered a new system, then you would comply with all those other requirements we talked about for ducts insulation, your air leakage, et cetera, et cetera. And if you have questions, or later on have questions, or once you dig into this and you realize you can't find the answer in these slide decks or your notes, please contact us through 3C Ren for your Code Coach service. And with that, Sarah is going to wrap it up, and we might have a minute or two for any additional questions.
Yeah, I'll just go through this closing slide real quick because I do believe we have a question in the chat. So thank you all again for joining us today. There are continuing education units available for AIA and ICC. My email is there on the screen if you need to send me your ID numbers. As Jennifer mentioned, the slides and recording will be going out by the end of this week. To your inbox. There's also a survey that really helps us out. So we ask that you please take that. And then we have a list of upcoming courses. April is a fairly busy month. The next few months will be pretty busy. So check out some of these course descriptions. They're on our website, and please register. And with that, we can go to the question.
Yeah, if anyone has questions, we have a couple minutes and we'll stay on a little longer if people are actually coming in with questions. Jennifer, Helen asks if there was a size threshold to which the new addition code items apply, or if they only apply to the whole area of the addition. She had an example. If you're doing a kitchen remodel and you want to install gas appliances, do you need to add wiring for electric ready within the kitchen?
Yes. I believe, well, it depends. I mean, when you say remodel, I mean, are you creating a new kitchen inside every dwelling unit for the whole complex? Or are you, or is it just like appliance replacement and repair?
Helen, feel free to unmute if we're not hitting your question right. My understanding was
that, was a single family question, you know, that because this is following the single family requirements in many ways.
I was probably just thinking single family, but I guess my question would apply to, you know, apartment complex or something like that. And sometimes they do them like one tenant at a time, you know, go in, do a remodel. Or I guess it would not apply for, it wouldn't apply to an appliance replacement, I'm assuming. Just because you can still replace appliances with what you want. That doesn't fall within the energy code, right?
Right. I mean, if there's gas there already and you're just replacing it with gas again, but a lot of our multifamily projects, I mean, they're already having electric for the cooking anyway. But the code just kind of clarifies that if you are building new and you were planning to run gas everywhere, you also have to run electric everywhere.
Right.
So that you can easily put in the electric or the induction at a future date.
Right. But if you had an existing, let's say, older apartment building and you were redoing, you're redoing the kitchens, you wouldn't have to put electric in. Let's say they have the gas infrastructure already and they were using gas appliances. I'm assuming that in your remodel, you can stick with gas, but would you need to run electric ready as well?
No, the electric ready is for new construction.
Okay.
Yeah, but that's a good question and something someone might want to consider because they're doing it now. That would be the time to do the electric upgrade if that was part of the whole project,
Right. The problem is
It
if they already
depends.
have the problem is if they already have gas, it's probably cheaper for them just to put the
Right.
gas in, unless the electric ready is a requirement, and then
Yeah.
they could do
Yeah.
As an
So the
alteration,
electric-
it's not required.
Yeah, it's
Okay.
a new construction
Yeah.
requirement, new construction. And then it just becomes, nuanced after that, what they want to do.
Okay, thanks.
Yeah.
Sure. We have another one that is, if there is a performance-based model that would allow for electric radiant heat. In my experience, no. As soon as you plug in electric resistance heat in just about any case, the things start to fail. California doesn't like it. There is an allowance for supplemental heat. We use a lot in like single family projects for like bathroom floor mats, and they have under 2 kW for the home, and you have to have an actual timer, a twist timer. So you can't just tie it to your thermostat and accidentally run it while you're on vacation.
Right. And that's why they're kind of really spelled out. And you'll get a copy of the slide deck sort of spelled out, like all the exceptions or when you can keep that existing electric resistance heating in an existing project. They realize that to change all that is cost prohibitive. So there's a bunch of exceptions of when you can keep it, but for new construction,
They shut it down pretty hard, yeah.
It's hard. They probably can't do it. I mean, theoretically, there might be a way, but no.
We've done it in old code cycles, but it was a lot of additional measures to offset the huge penalty. And I haven't tried to do that in a couple years now because no one seems interested in it.
Yeah. It's like, doesn't really pencil out after you do all the other measures. Yeah.
May I? It's okay if
Yeah,
I
please.
ask?
Yes.
I'm just, we have it at home, and this project, which is, I'm just thinking to the point where if it's getting close to super airtight, and and that's what I mean by almost a passive house approach to it, then radiant heat can become so efficient at that point. And that's sort of, amazingly ridiculous that you wouldn't be able, to do that. But of course, that's the code. So I do want to add also that there's a company in Berkeley that's starting to develop similar to I really got excited about what you said about the instant hot water, and I looked it up while we were talking. There's a company in Berkeley who's creating an induction stove that has also a built-in battery, which also allows for regular electric hookups. If anybody's like, oh, I don't want to run, upgrade the wiring, they can do it with existing wiring and still use and so you have a built-in. Speaking of resiliency, you mentioned that, Jennifer, that the stove itself becomes a both battery and a power for the induction, which is kind of cool. So anyway,
really cool.
I'll be quiet.
No,
That's really cool.
Yeah.
Send me that link. That's a new, I hadn't heard of that one. That would be really cool.
I'll do it right now.
Oh yeah, maybe you put it in the chat. That's interesting, Grant. I seem to have.
Yeah, we're going to see a lot of these new ideas. So that's cool to hear.
Interesting.
Yeah,
and that one, it's called IntelliHot.
Yes, I just found it.
Yeah, I reached out to the rep, and the rep said, "Oh yeah, I'll send you all the information you need," but they didn't specifically answer my questions yet about
that would be awesome, because
battery and all that. And it's just an interesting idea.
Yeah.
And we'll find out more, maybe more webinars coming up when we address. It's kind of, because a lot of folks are like looking at on-demand systems, but also maybe for commercial systems, they already have a battery requirement, or maybe the water use is so intermittent that they don't want the big tank of hot water sitting there. So they'd rather just have that energy stored in a battery ready to do the on-demand. And it's enough to kick on, heat pump instead of electric resistance.
And there is the radiant still through, which is really interesting, like radiant panels, and these are the ones like actually I like on the ceiling, but still then go back to a heat pump rather than just direct.
Right.
So those are, I forget what they're
Yeah.
what they're called.
I've seen those before in hospital.
Right. So depending on your budget, right? We've had clients who have done radiant heating via water loops where they've heated that hot water with heat pumps. I've had a couple clients who do that. It's not inexpensive. I would not imagine that that's a thing we're going to be seeing in a multifamily housing project, but we've had a couple high-end custom residential where they've gone that route. Yeah, I think for multifamily, one of the more interesting solutions on the heating, space heating for really small, that kind of addresses what you were saying. Well, if the whole building is energy efficient, the whole building is tight, it seems kind of overkill when you talk about these heat pumps, but we've got a project that's using like a PTAC heat pump, but they've got a special kit to make sure everything is sealed better when you put it on the wall. And it's using R32 refrigerant, which has a much lower global warming potential than the other refrigerants typically used in PTACs. So that, and it's a heat pump, and it works for small, it works for really small apartments. In this case, they were one-room apartments, so they could use that one appliance, and it was cost effective. And there's another little kit you can add to it to side heat a bedroom for a one-bedroom apartment. So that's under construction now. I'll love to see how the folks like it after they move in and live with the appliance. There's some appliances out of Europe that are heat pumps, but they look better than like our PTACs that we think of as being in hotel rooms. They're really nice looking. It just looks like a nice thick wall assembly under a window. It's all built in. And so I'm looking forward to seeing if some of those might be appropriate too for our multifamily projects. Grant, what did you guys end up using on those towers, those down in LA? What's it? Those
I had to look up the spec. That was making sure that was a quality PTHP too. The trick there was having 2 fans, so that was like a dedicated. We were addressing the outside air requirements, so there was like a dedicated supply and exhaust fan inside the terminal unit. So we were able to utilize that as like a balanced ventilation source. It was interesting. Right. Yeah, I could pull the spec somewhere.
Yeah.
Yeah, well, thank you all again for staying over just a few minutes. We appreciate the extra conversation, which is great. I'll go ahead and end the course here. The slides and recording will be coming soon. I'll get those out probably by tomorrow, and hope you all have a great rest of your day.
Thank you, everyone.
Okay, thank you, everyone.